Hey everybody, Mr. Troy here. Bonus video. I'm going to do some problems that I have never seen before to try to give you guys an idea of how I think about problems. I will skip problems that might not be appropriate for us right now, but these problems over here, I don't know ahead of time, so we'll see how it goes. Here we go. All right. So, let's see, negative 2k to the fourth plus 2. So, negative 2k to the fourth plus 2. This is a little bit past where we'll go in this unit, but we will certainly see this later on, so I'll show you. I'm going to always start by factoring out a greatest common factor. In this case, it is negative 2. I'm going to look at this, and this is actually a difference of two squares, like we talked about in class, because k to the fourth is k squared squared. Now, k squared plus 1 is not a difference of two squares, but k squared minus 1 is. So this is going to factor to k squared plus 1 times k plus 1 times k minus 1. If you followed that, good. If you half followed it, that's okay, because that's a little advanced. Okay, next problem. Yes, this is totally in our wheelhouse. So, I have 4 terms. But first, I have a greatest common factor. Everything is divisible by 2. So I'm going to start out by pulling out the 2. So 2 times 2c cubed plus c squared plus 2c plus 1. Then to decide if you can factor by grouping, you're looking for this pattern of 2, 1, 2, 1. I can. So c squared times 2c plus 1. And this has to be 2c plus 1. And the only way to make that possible is with a plus 1. So then this is going to become 2 times, remember the two outer parts go together, so c squared plus 1. And the inner parts get factored out, and they just count once. So don't double count that. But that is how that one factors. All right, next problem. That's going to be similar to that's the exact same problem as the first one. Similar to the first one. Okay. So 9a to the fourth minus 6a cubed plus a squared. I'm going to start by factoring out a greatest common factor of a squared. And that's going to give me 9a squared minus 6a plus 1. Okay, so remember, to see if something was a perfect square trinomial, we want to look at this term and that term if they are both perfect squares. 9 is a perfect square, 1 is a perfect square. So my guess is that this is going to factor to 3a minus 1 times 3a minus 1. The negative 6 comes from negative 3a here and negative 3a there. And then most people are going to write that as a squared times 3a minus 1 squared, or twice. All right, now we're having fun. Let's see another one. Okay. A factoring by grouping problem? Probably. Let's see. So negative 2a to the fifth minus 3a to the fourth plus 10a cubed plus 15a squared. Now, there's no common factor that goes all the way through, except for the, oh, there is the a squared that goes all the way through. Okay, so I can do that. I can pull an a squared out front. And actually, here's what I'm going to do. I'm going to pull a negative 1a squared out front, just because I like to start off with positive numbers. So that's going to give me 2a cubed plus 3a squared minus 10a minus 15. You can mix and match your parentheses in order to make it so you can tell that everything is different. So a lot of times for our outside parentheses, we'll use the bracket. Don't confuse with interval notation. It's just a way of making things look visually different. Okay, so there is still a greatest common factor with the first two terms. That's a squared times 2a plus 3. And then to make the second part 2a plus 3, I need that to be minus 5, so that when I distribute it in, I get that negative 10. So this is going to be negative a squared times a squared minus 5 times 2a plus 3. All right, I'll do one more. Done one like that, done one like that. Too easy. Done one like that. Come on, guys. These are just randomly generated, so I don't really have a choice here. Okay, this is kind of different enough. So, negative 12m squared plus 2m plus 14. Okay, so I'm going to start by factoring out a negative 2 because everything is even, and I would prefer to start with a positive 6 as opposed to a negative 6. So 6m squared minus m minus 7. Okay, so let's see. One thing I'm noticing here is that 6 and 7 are close to each other. So let's see how to put this in words. This could either factor to 3m and 2m, because that's one way to make 6, or it could factor to 6m and 1m. Now the good news is that 7 doesn't have a lot of factor pairs. It could be, you know, +1 minus 7 or -1 plus 7. So because of that, I think about it this way. This is going to give me positive 6m, and this is going to give me negative 7m. And when I combine those, I get that negative 1. So this is going to be my final answer. Okay, I'll do one more because we're going to do that in a later unit. So let's find a good one. Okay, this is a little bit better of an example. So 5t cubed minus 13t squared minus 6t. I'm going to factor out the t, and I'm going to get 5t squared minus 13t minus 6. Okay, so since 5 is prime, the only way to do that is to do 5t and 1t. There's only one option. So my factors of 6 are 1 and 6 or 2 and 3. Now, the thing that pops into my head is that 5 times 2 is 10, and 3 makes 13, or 5 times 3 is 15, minus 2 makes 13. So I just have like numbers bouncing around in my head. So if you're doing this, you might say, okay, if I do plus 2 minus 3 to multiply to make negative 6, that would give me 10 minus 3, which would be positive 7, so not the right idea. So I'm actually going to do the negative 3 here, and that would multiply to make negative 15, and the positive 2 here. Negative 15 plus 2 is negative 13. So this is my final answer. All right. Hey, I hope that helps in some way. It's fun for me to do math. Anyways, bye.